So now we're going to use ChatGPT to help us further reinforce combinations and permutations. And so I'm going to come to ChatGPT and I'm going to say, can you please give me a problem to practice? Can you please give me a problem to practice using combinations to determine my sample space? We'll see what it says to that. Certainly, here's a practice problem that involves using combinations to determine the sample space. Problem, you're part of a 10-member committee and you need to select a 4-person subcommittee to work on a special project. The order in which the members are selected does not matter, so you'll be using combinations to determine the number of possible ways to form the subcommittee. How many different 4-person subcommittees can you form from the 10 committee members? To solve this, you'll need to use the combination formula, where N is the total number of items, in this case 10 committee members, and R, again here, you see different notation, don't sweat it, don't stress it. So, you know, ChatGPT is built upon all of the knowledge that's available in the world online. And so based upon that, R is commonly used for this. And so that's kind of good to know that adults are inconsistent, which they are 100%. Like one of the greatest farces in the history of humanity for me is that at one point they had rational economics. Like economics was originally based upon the fact that humans were rational beings. 100% we're not. So anyhow, here's R is the number of items to choose. In this case, 4 members of the subcommittee. Calculate the number of combinations to determine the sample space. So we're going to have 10 factorial, and then it's going to be 4 factorial times 10 minus 4, which will be 6 factorial. So we need to figure out 10 factorial, we need to figure out 4 factorial, we need to figure out 6 factorial. And so I'm going to go to Google and I'm just going to say equals 10 factorial up here at Google, and I get this number, okay? So that's 10 factorial, so I'm going to copy that, and I'm going to put that, I guess I'll go over here. I wonder, you know, I'm just going to do a new sheet, and I'm going to do 10 exclamation, and I'm going to do equal factorial, and factorial of a number. Great, that's the one I want, and I'm going to do 10. And then I'm going to do, I need 4 factorial, right? And that's going to be equal to fact, and that's going to be 4. I like this better. And then we're going to do 6 factorial, and I'm just putting these here so we know what each one is, and we're going to do equals fact, and we'll do 6 we'll do 6 right there. I don't need that because it's just passing an argument into a function. And then to calculate my combinations, it's going to be equal to this number here divided by the product of this number times this number, and that'll tell us how many different combinations we have, which are 210 different possible combinations. Let's see if we got that correct. And so we're going to say my answer is 210. Is that correct? That there are 210 different possible combinations. Yes, that's correct. You applied this correctly, and there it shows me the math and lays it all out. What about if I'm having the committee members sit in a certain order in the room and the order matters? Would I have, and so to do order, we're going to take out that 4, remember? So I'm going to come over here and I'm going to go back to my spreadsheet, which is actually right where I was at. It's right there. And I'm going to do permutations. And I'm going to come up here and I'm going to make all of these references. I'm going to make them absolute. So I'm going to make that absolute. I'm going to make that absolute. I'm going to make that absolute. I'm making those references all absolute so that when I copy this, hey, come on. When I copy this, Control-C and paste it here, Control-V, the same formula is copied there. But remember, to do permutations, we don't have that first number, which is the B2, which is the 4 factorial. We just have that, right? Because here, our formula is just the total number, which is going to be factorial 10, all over the large, which is 10, minus the 6, minus the 4, which is the 6, right? Factorial 6. So because we're selecting 4 members out of 10. And let's just check that to make sure that's what the problem was. Select 4-person subcommittee out of 10. And so to do that, we're going to select 10 minus 4, or 6 factorial, which is B3. So it's going to be the total number, 10 factorial, which is B1 right there. And it's going to be divided by 10 minus 4, which is 6 factorial, which is B3 right there. And so when I calculate this, I get 5,040 possible permutations. And so would I have 5,040 possible permutations? And so I ask it that question, and it should say, yes, you're correct. When the order in which the committee members are seated matters, you would use permutations instead of combinations. You have 10 committee members, and you want to arrange 4 of them in a specific order. Since order matters, you'll be using permutations. So here's the permutation formula, P and R, and P10 4, right? And then there, and so that's it. Can you please give me one more problem that deals with permutations? I kind of like this. It's kind of fun. And it's like working with a tutor, and it really kind of shows you and drills you and then gives you the answer and explains it. So here is 8 participants, and you're doing gold, silver, and bronze medals, the top 3. So you're organizing a race with 8 participants, and the top 3 finishers receive gold, silver, and bronze. The order in which they finish matters because the medals are different. So we need to do 8 factorial divided by 5 factorial, and 5 factorial because 8 minus 3 is 5. So we'll come over here and we'll do 8 factorial. 8 factorial divided by 3 factorial because, wait, it's going to be 5 factorial. 5 factorial because, and I'm actually right here, it's 8 minus 3 is 5 factorial. And so do my equal sign, fact, and we have 8. And then do my equal sign and do fact, and we have 5. And then we're going to do permutations, and I'll just copy that from here. Permutations is going to be equal to this divided by that, and we're going to have 336 permutations. Doesn't seem like that many, right? You know, if we have 8 participants. So we'll come over here and we'll say, is the answer 336? Yes, that's correct. Yay! So here we have 8 participants, 3 medal positions to be filled, and we've got 336. So there are 336 different ways to award the gold, silver, and bronze medals to the participants. Like, what if there was, like, you know, I don't know, I'm kind of curious. Like, what if there was, I'm just going to copy all this, Control C, and what if there was, like, you know, 100 participants, and 100 minus, and so 100 participants, and so the problem is 8 participants and top 3 finishers, so 100 minus 3 will be 97. 100 minus 3 will be 97, so we'll do 97 here, 97 here, and then we'll change this to 100. And I'll do this, I guess, in formula view, and we'll change this one to 97. Right? And now we're going to find out, like, how many permutations are there when you have 100 participants and 3 medals and the order matters. There's 970,200 permutations. That's pretty cool. And there's one more example, which is kind of fun. Like, you know, can you give me an example of combinations in relation to the, what is the lottery? The big Powerball lottery, possible numbers to choose, right? So Powerball lottery, 5 numbers from 1 to 69, and so we'll just copy all this. And so here we'll put this in to the Powerball lottery. Can you give me an example of combinations in relation to the Powerball lottery? Remember, the Powerball volume, you must pick 5 numbers from 1 to 69, and the order doesn't matter on that. And can you please show me how to calculate the combinations, because the order doesn't matter, or is it permutations, or is it permutations, or some combination of that? For the Powerball lottery, right? So let's see what it has to say about this. That's kind of interesting. To calculate the number of possible outcomes, right? So an outcome, we have an experiment, and then, you know, experiments have outcomes, and then the sample space is all the possible outcomes. To calculate the possible outcomes in the Powerball lottery, you're dealing with a combination for the white balls and a simple choice for the Powerball number. Here's how you break it down. Calculate the combinations for the white balls. Combinations. So combinations is this. We have 69 total number of white balls, and 5 is the number of white balls you need to pick. So 69 factorial, and then 5 factorial, and then 69 minus 5 is 64 factorial. And so 69, 5, 69 minus 5, and we do all of that, and we get this here. And number of possibilities for the Powerball, there are 26 possible choices for the Powerball, and this actually goes on. There should be dots there. And 5, 4, 3, 2, 1 is that first part, but it's kind of not expressing this correctly over here, right? So there are 26 Powerball possible choices for the Powerball, which is like, I guess, this other one. And total possible outcomes, multiply the number of combinations of the white balls by the number of possibilities for the Powerball. So maybe that's like multiple steps, right? And because that one is, you know, number of outcomes in the first step times the number of outcomes in the second step. And let's calculate these values. Combinations for the white balls, the number of ways to choose 5 numbers from 69. The white balls is this. And when you multiply that by the number of combinations for the white balls by 26 possibilities for the Powerball, you get that. So there's 292,201,338 different possible combinations for the Powerball ticket. And we're going to calculate that because I'm not sure that's correct. So we're going to pull this out, and we'll put it to the side over here. And then we'll grab this and put it over here, and we'll go to our spreadsheet. And at our spreadsheet, we'll pull these down. Wow, that's kind of interesting. It gave me scientific notation. And you could put that into ChatGPT to have it explain scientific notation. But we're going to do 69 factorial here, and then we'll do 5 factorial here, and then we're going to do 69 minus 5, which is 64 factorial here. And so we'll do equals fact, and we'll do 69 there, and equals fact, and we'll do 5 here, and we'll do equals fact, and we'll do 64 here, and so that's what that looks like. And so scientific notation, you know, if I copy this, it's going to give me that there. If I copy this here, right, like I'm just trying to figure out how to copy that number. If I bring it over here, it'll put it like that. Can you please explain this to me? All right, and it'll show us a little explanation of scientific notation. But while it's doing that, I'm going to do equals. It's going to be equals to this divided by this times this. All right, so I messed up. Let me Control Z that. So it's going to be equal to this divided by this times this. Boom. And so we've gotten that, and that, if we go up to format and we say we're going to format that like a number, we could format it like this right there. That's with decimal places. But if we go back now after we've chosen that formatting and go to format number custom number format, it'll show us what it took to format that. I'm just going to pull those decimals off, right? But that's the notation for formatting it like that. So I'm going to click apply. It's 11,238,513, and we got up here 11,238,513. And then down here, if we multiply that by 26 equals that times 26, multiple steps. And then we're going to take the formatting, go back up here to format, and go to number, and we could just go down and enter it custom if it's not there. Yeah, that's the one I want, just like that. So 292,201,201,338. So got it right. And I was a little confused by that because what are the odds on the Powerball lottery? Because I thought they were like in the 400 millions. No, it's 1 in 292 million. That's kind of cool. So what is the Powerball lottery? Powerball lottery now, right? And the Powerball lottery now is, let's just go to the home. And so the Powerball lottery is only 34 million. Reject all. And but let's say it was like 1.5 billion. If it was 1.5 billion, Wednesday, no, I don't know. If it's 1.5 billion, so let's say 500 million, 1, 2, 3, thousands, 1, 2, 3, 1.5 billion, and we have equal to this divided by that, right? That's like 5 times your odds. So if it's 1.5 billion, and that 1.5 billion would actually be 750, 1, 2, 3, 1, 2, 3 million, because they discount it. That's 75 million. I want 750 million, right? So that'd be like 2.5 times the cash value is what you get if it's 1.5 billion. And so you could say, okay, I'm going to spend $292,201,338 and buy every ticket. Buy every ticket, buy every number, cover every number. You're guaranteed to win. And that jackpot is going to kick out $750 million, which will, you know, if you're the only winner, it's going to more than double your money. It's going to 2.5 times your money. But if there's 2 winners, you're going to split it with somebody. So you'll get 1.25. You'll get 25% on your money. If there's 3 winners, and at some point maybe we could calculate the odds on there being 2 winners, of there being 3 winners. If there is 2 winners, 3 winners, you would lose money. But what are the odds of that? You could look at all those odds, very numerical, very mathematical, very certain, right? And you could say, let's place that bet. Let's place that bet. I kind of like that. I think that'd be kind of cool. All right, cover every number. So that is that's doing permutations and combinations and multiple steps. I enjoyed that. I got a little bit excited. How often do you get to say that about statistics?